Hi everyone, thank you for taking your time to join our webinar. I'm Jason Ng, the SVP of ADLINK Technology in charge of the Smart Factory solution. The topic today tells you we are going to talk about how legacy machine can transform into a modern light machine. Before we start, let's have a recap of the Industrial Revolution. During the Industrial Revolution 3, the key focus is on automation. Comes Industrial 4.0 is about data collection, analytics, data modeling, and control. In the recent years, AI has been introduced to further improve the process of work. Today, we are going to focus on data collection, AI integration, and automation for the legacy machines. Today's content: 1. Introduction to ADLINK Data Extractor, the DEX100. 2. .NET, a solution for adding SexGem to the legacy machines. And number 3. Adding machine learning to the legacy machines in a non-intrusive way. The DEX100 targets to extract machine data in a non-intrusive and scalable way. If you walk into a factory today, you will see most of the PC-based machine will have a display monitor attached to it through VGA or DVI cable. We will detach this VGA cable from the monitor and connect to the DEX100. The display image will be captured, then go through an OCR process converting image to data. The data is then sent to the top floor in a normalized format. DEX100 can also control legacy machine through mouse keyboard signal. Now, you can assume the VGA signal as the eye of the operator, and the mouse keyboard signal controlling the machines as the hand of the operator, making DEX100 a virtual operator. DEX100 not just collect machine data, it collects real-time information of the production status as well as the machine status. This information are important for the management production planning as well as for machine optimizations. Adding new features will extend the lifespan of the legacy machine, which otherwise may need to be scrapped as it may not meet the customer new process requirement. The biggest challenge is that SI is not allowed to add new programs to the existing machine controller. But with DEX100, you can extend the new features by adding sensors, actuator, programs to DEX100, then interface DEX100 with the legacy machine through VGA, mouse, and keyboard signal. Ever wonder how your legacy machine can be enabled with SexGem capability without adding any programs to the machine? Here, we introduce a partner solution, the Sex2Dex.net, developed by Inspire Technology. Sex2Dex.net is a fully configurable solution without coding required. It is an interface layer converting all the data extracted from DEX100 into SexGem protocol and send the data to the host controller automatically. You just need 3 simple steps to get your legacy machine SexGem ready. Step 1. Connect DEX100 to the legacy machines through VGA, mouse, keyboard cables. Step 2. Configure DEX100 to capture the required data through OCR table. Number 3. Integrate and test Sex2Dex.net with the host controller. With this, you can run DEX100 program and all the data will be collected by DEX100 and transferred to the host controller via SexGem protocol. This is an example to show machine image captured by DEX100 via VGA signal. Data that needs to be collected are box red. Once this data are collected, it will pass to SexGem daemon converting this data into SexGen protocol and transfer to the host controller automatically. Not only is sex2deck.net collect data, it can also issue command to the legacy machine from the host. This example shows how the host send command to the machine to automatically load the lot ID and the recipe for use, followed by a start command to the legacy machines to run the lot automatically. So, step 1, the host controller send a S2F41 together with the lot ID, recipe ID to DEX100. DEX100, upon receiving it, will automatically key in the lot ID and recipe ID into the machine. Upon completion, it can start the machine to start production automatically. The host controller can also send a terminal message to the display of the legacy machine to give instruction to the operator. Just like in this case, the host controller detected a wrong recipe loaded by the operator. It can then send a terminal message to the operator requesting the operator to stop the machine immediately. AI has been a very hot topic, and user has acknowledged the benefit of AI to enhance the features, functions, and performance of their products. It frees up workers to be more creative by automating tasks, reduce headcount through automation. But challenges also acknowledged by both the user and the SI. It is difficult to integrate cognitive projects with existing processes and systems. One of the very common pain points in the factory is how to reduce the AI machine false reject rate. This is because AI machine usually set very high confidence level to ensure no false acceptance. Also, certain defects are very challenging with rule-based inspections. These rejects will need operator manual inspection for confirmation, which is very time-consuming and prone for human error. Since AI algorithm is trying to resume the human brain thinking process, it is ideal to replace human inspection with AI technologies. The challenges of integrating AI systems to existing legacy machines are as follows. 1. Existing legacy machine fail to release image for AI training and inference. 2. Existing legacy machine fail to provide operator result for AI labeling. 3. Even with the above two conditions met, AI inference result fail to feed back to the MES automatically and need operator to key in the result. Here, let me introduce you another product, the DEXSIM. For AI training, we need image and labeled result. To replace operator, we need to replicate the operator action automatically. DEXSIM is a 3-in-1 solution where it captured image automatically for AI training and AI inference. It captured the operator labeled result in the background automatically. It also captured the operator data entry procedure automatically. After AI inference, AI will return the inference result and entry procedure. DEXSIM will then replicate this entry procedure back to the system automatically. Now let me play this video to show you how DEXSIM works. During normal operation, operator and engineer will respond to the content of the display shown with mouse and keyboard action. With DEXSIM connected, it records the human operation by recording the display output of the machines the operator or engineer's keyboard and mouse action simultaneously. These are then sent to AI server for machine learning to build the AI model. During production, DexSim will capture the display image of the machines and send it to AI server for inference. AI server will then not just return the result, but also the keyboard and mouse action previously captured by the DexSims, allowing DexSims to enter the action automatically back to the machine's PC. In this way, it replaces the operator seamlessly. Let's go through a use case in the semiconductor industry. After AOI inspection, the wafer is sent to the operator for manual inspections as AOI machine generate many false rejects. Such a process is tedious, time-consuming, and prone for human error with inconsistent results. The solution is AI interception. Instead of the operator doing the inspection, the task is offloaded by AI. This will improve the yield and efficiency, but this interception poses many new challenges. In order for AI to work, it needs image and labeling results for training purpose. It will also need real-time image for inference. Unfortunately, the AOI machine or manual inspection station may not provide image for AI training and AI inference. Even if there is image, we are not able to get the operator result for labeling. During operation, inference result from AI may fail to be feedback to MES, and this need operator to key in manually, which is very tedious and time consuming. The solution is AI plus DexSim's interception. DexSim will capture the display image from the manual inspection station and send to AI server for inference. AI server will then send the result and the operator key-in procedure to DexSim, and DexSim will follow this instruction to key in to the manual inspection system automatically. In this way, operator can be removed. Here I would like to introduce another partner solutions, Image AI. They use DexSim with their AI for post-wafer AOI inspection. Before implementing it, the yield rate was 95%, but after implementing, the yield rate improved to 98%. At the same time, operator is removed and the review time is greatly reduced. Another use case is in the SMT line. AOI machine usually report very high false alarm rate. It can be up to 99.5% of false reject. Almost every single board needs to be inspected manually, affecting the throughput. Furthermore, skilled operator is difficult to recruit. Inconsistent results from different operators also contribute to loss in quality. Here, I shall introduce to you another ADLINK product, the AI for AOI, which we partner with another AI company. The solution specially focuses on SMT AOI false call reduction. In the current process, after AOI, operator will need to manually inspect almost every single board. With Dex AI for AOI solution, Dex AI will capture the image from the AOI system, then crop the image and pass to AI server for inference. The result from the AI server will pass to Dex RS, which will then key in automatically back to AOI system. In this way, operator can be replaced. We have come to the end of the presentation. Thank you for listening.